So the question that we're given is to create a formula that applies to the constraints given. So reading the question, we got the polynomial of degree 5, p of x has a leading coefficient 1, roots of multiplicity 2 at x equals 2 and x equals 0, and root of multiplicity 1 at x equals negative 2. Find a possible formula for p of x. Okay, so we have a couple of different parts of this. So to start, the polynomial of degree 5. So a polynomial of degree 5 means that whatever variable in that formula has the highest degree, that's going to be what defines the polynomial's degree. And to kind of show what I'm talking about, we got this. So f of x equals 2x squared plus x plus 3. So the variable with the highest degree is right here. We have this x equals 2. So this would define this polynomial right here as having a degree of 2, because this is the highest one. And then we have the second part. P of x has a leading coefficient of 1. So going back to this example, the coefficient is going to be the coefficient in front of this variable that defines the polynomial's degree. So in this case, we have 2. So this function right here is a polynomial of degree 2 and has a leading coefficient of 2. Okay, great. So we got the first two parts down. And then we have roots of multiplicity 2. So multiplicity, that refers to the amount of times that a root or a 0 value is how many times that appears in a polynomial. And that will show us how a formula, how that looks like on a graph, whether it breaks the axis or does a bunch of things. And that I would explain that, but it's not mentioned right here. Right now we're just trying to find the formula. That's what multiplicity is, how many times that root appears in a formula. And we got this example right here. So we got f of x equals x squared minus 6 plus 9. So it's a little bit difficult to tell right here, but this has at root x equals 3, there's multiplicity 2. And it's made a little bit more obvious when we simplify it down to this. F of x equals x minus 3 squared. So this means that at 2 places, or it doesn't mean at 2 places, it means that the root x equals 3 appears twice, because when this x value is 3, this equals 0. So basically, this value we have up here, this is the multiplicity, right? Oh, courtesy. This is the multiplicity of the root, okay? And so that basically means that when x equals 2, that phrase is going to be squared. And when x equals 0, that phrase is also going to be squared. And then when x equals negative 2, that phrase is not going to be squared. This is going to be to the root of 1, which is not going to, or to the power of 1. And then this will be broken down to what we got. So we got our p of x, that equals 1, which is going to be our leading coefficient, x minus 2 squared, because when x equals 2, it's going to be 0, got the multiplicity right there, times x squared, when x equals 0, it's 0, and then when x equals negative 2, it's not squared to the power of 1, and then when we write that out, it'll look like this. And just check, make sure we got everything we need. Polynomial of degree 5, got that, check. Oh, that's supposed to be a check, there we go. Coefficient 1, got that, check. And then right here, we can see where our multiplicity standards come in. And this is basically a 1 right here. So all these criterias are met, and we found a possible formula for this p of x. All right, I hope this helped. Thank you very much.